Hi, I'm Iain and welcome back to the Northland Workshop. Today we're over here at the lathe because I have an interesting project. And that project is to build some handles for some old chisels, because as a woodworker I seem to acquire old chisels. They just pop up from time to time. You can get them for about $1 at a yard sale, sometimes even free. But wherever you find them and whatever price you pay for them, two things are usually constant. One is they're in desperate need of sharpening, and two, they're missing their handles. So today we're going to fix one of those problems, and that is the severe lack of handles. We're going to make a handle for this chisel right here. Here's the handle. And we're going to make a handle for this chisel. And the reason I've chosen these two chisels is this one is an example of a socket chisel. And what I mean by that is if I wiggle it back and forth, you can see that the handle pops out of the metal chisel and it has a tapered hole at the end of the blade into which this tapered tenon goes. So I go over how to size the tenon to the socket, and then the rest is really just making it whatever design you like and that's comfortable to you. If you can make a socket style handle, you can make a handle for a tanged chisel. And what the tang is a piece of metal that actually extends up into the handle a ways. And really the tricky part of this handle is drilling the hole so it's straight and centered in the handle to fit the tang of the chisel. And we'll go over that too. So in this video we're going to cover how to do a handle for a socket chisel and how to do a handle for tang chisels. So that way, no matter which style of chisel you happen to have, this should help you build a handle for it. And really, once you've done one, you realize there's really not that much to it, and you can crank out a whole lot of chisel handles in a hurry. I figured we'd start with one of the socketed chisels because cutting the taper is kind of intimidating, but if you take your time, it's really not that bad. The first thing we need to do is figure out the length of the taper. So I've got a 1/4 inch dowel, and I'm just going to stick it down in there and mark a line where it contacts the edge of the socket. Now I'm going to take that dowel and transfer the line to the handle blank. And so now I know this is the length of the taper to the very bottom, because the very bottom of the socket is a 1/4 inch. So when all is said and done, we'll have to trim it off a little bit so that way it's not bottoming out in the socket, because you always want to have a little bit of space at the bottom of the socket so as the wood shrinks or compresses with the hammer blows, it doesn't bottom out, because once it bottoms out, it'll loosen up. So you want it to have a little bit of space there. So when we're all done with the turning, we'll actually turn the taper back just a little bit, but we'll worry about that when the time comes. First, we want to make this thing fit this socket. The other thing we want to do, now that we know the length, is we need to know the maximum diameter. So I've taken my calipers and I've set them to the maximum diameter of the socket. So as I start turning this down, I'm going to turn this section into a cylinder with the diameter that is as wide as the widest part of the socket. The rest of it will get tapered down, but I'll know the top part is the correct length. I should mention that I'm going to be using a carbide cutter for this operation because I find it's a lot more exact to size something with scraping it to dimension than it is with some sort of slice and cut. For me, it's just too easy to get overzealous with a peel cut with the skew, and before I know it, it's smaller than it needs to be. On decorative stuff, doesn't really matter if it's a couple thousandths too small, but where we're trying to fit this into an exact sized housing, it's going to make a big difference. So I'm going to use the scraper for the tenon, and we'll see what I end up using for the rest of the handle. Maybe it'll be the scraper, maybe it won't be. It all depends how I feel at that time. First thing I want to do is turn on the lathe and transfer this shoulder line all the way around. Now we can go ahead and start turning. Now that I've got the maximum diameter set to the maximum diameter of the taper, I can work on this end. And this is where it's going to get interesting, because this is an antique lathe with a dead center with a cup on it. It's not going to allow me to get in as narrow as I would like if it was a cone center with a ball bearing on it like a modern lathe. However, there is one advantage to this dead center, and that is that the metal doesn't move. So if I touch it with the cutter on the turning tool, nothing bad is going to happen because this is stationary and the cutter is stationary. Only the wood is moving. So what I'm going to do is start reducing this end of the tenon, tapering it down, and I'm going to keep taking it off and testing the fit on the chisel. I want to make sure this thing fits correctly before I do the rest of the turning on here, because if I mess this up, I can always trim it off and I have enough length left over to try it again. I don't want to take all the time and effort of making a nice handle just to mess up the taper. One thing you'll notice is I go from the wider part to the skinnier part when I move the cutting tool. I don't go back the other way. There's two reasons for that. One is it's a holdover from using the cutting edge tools where you always want to cut from the larger diameter to the skinnier diameter, but also even with scraping, you really don't want to go that way on a taper because it's just too easy for the corner to dig in and suddenly you've made a whole series of steps instead of a smooth taper. Now what I can do is go ahead, take this out. You'll notice there's this little burr on the edge from where the wood was actually in the cup center and I wasn't able to get it with the turning tool. I'm going to take this other 1-inch chisel and simply trim that off. And with that little ridge on the end gone, let's see how it fits. So, if I put it on the chisel and I spin it around, you can see that it looks like we're touching just about everywhere. So that is not too bad. Now, if I tip the chisel back and forth ever so slightly, I can feel it rocking, which means that it's contacting down here slightly more than it is up here. Therefore, it can rock like this. So, what I want to do is trim this down just a little bit more and try it again. The other thing I can do is take the tool rest and tip it so it's approximately parallel to that, and that'll just make it a little bit easier to run my hand along and try and keep a consistent taper. I'm happy with how it fits now. I don't know if the camera can pick it up, but you can tell it's making contact right in here, up in here a little bit, and then right at the top edge. So that's what I want to see. The other thing is, if I tap it in with hand pressure, the chisel stays there. It doesn't pop back out unless I really pull on it. The other thing I tried doing was putting it on a scrap piece of wood and tapping on the end of this handle-like thing with a mallet, and after a couple taps I couldn't pull this thing apart without wrapping it on the bench. So I'm happy with that fit. I think it's going to be fine. Now we can go ahead and do the actual handle part of it to make it feel more like a chisel handle and not just a chunk of wood. I've made the executive decision because I have the tool rest set to the proper height for the carbide tools. I'm just going to go with carbide for this whole handle. I have this old chisel handle off a smaller chisel that I want to somewhat pattern this after. I want to make this one about 1/2 inch to 3/4 of an inch longer than this one, and I want to make it a little bit bigger diameter because, again, this is a bigger chisel. If I put this handle in, you can see that proportionally it should be bigger, but I like the style of this thing, so I think I want to replicate that. This part I think can be the same, and then if I just bring it out maybe 1/2 inch more, that should be good. And whatever I do to this handle, I'm going to replicate for this other chisel. The only thing that'll be different is this is a much fatter, shorter taper than the Stanley one. I've gone ahead and cut a couple little grooves in this just to mimic this antique chisel handle that I found, and I thought it just added some detail besides just being a plain old chisel handle. To accentuate these grooves, what I'm going to do now is sand it, put a coat of shellac on. Once that dries, I'm actually going to come back in with an artist brush and paint in the grooves. Once that's dried, I'm going to come back and sand that. That'll remove all the paint that's on the handle, just leaving behind what's in the groove, and that will get 2 more coats of shellac to seal it in. And I think that's going to add a lot of detail to this versus, once again, just a plain old chisel handle made out of ash, because ash is a nice wood, but it's kind of a plain looking wood, and I want this to be special since I took all the time to make it. Turning the handle for the chisel that has a tang instead of a socket was identical to turning the handle for the sockets, except instead of a tapered tenon at the end, I made a straight taper that fit this piece of 1/2 inch pipe that I'm using as a ferrule. And all I did, once I got it so it had a snug fit, was I took it off and epoxied it on, and then continued to turn the rest of the handle. And because this is a smaller chisel, I made this handle a little smaller than the other ones, so this is more of an exact replica of the original one. Where the big difference comes in between the handle for a tang chisel versus a socket chisel is now I need to drill a hole in here to accept the tang of the chisel. And this is tricky because it has to be exactly centered and parallel to the axis of the handle. Otherwise the handle's going to shoot off at an angle, and that's not going to work real well. The nice thing is that the cup center on my lathe left this nice center hole right here. And I know that's the center because that's what it rotated around. So everything's symmetrical around that point. So I can use that to start the drill bit. Now the issue is, how do I make sure that the drill bit stays centered in the handle? Well, to do that, I'm going to use my drill press with a simple jig. So let's take a look at that jig. And as you can see, it is a scrap piece of 1/2 inch thick, 1.5 inch wide pine that I drilled a 5/8 hole in with my drill press and a Forstner bit because I wanted to make sure that that was 90 degrees in all directions. And then I went ahead and cut out this rough wedge shape. And what this is going to do, and the reason I have it sitting next to my diamond sharpening plate, is I've actually been spraying this with water for the last 5 minutes and letting it soak in just to make it a little bit more flexible. What I can do is actually take the handle, stick the ferrule in the hole, and then clamp it. And when I clamp it, this thing's going to hold it so that way the handle is perpendicular in all directions to this scrap piece of wood. So I've got the jig clamped to the table, which is swung out of the way so that way the handle can hang down, and everything is perpendicular now because the table is 90 degrees this way and 90 degrees this way. I know that this hole is going to be parallel with the axis of rotation for the handle. And so the chisel should seat in there square when it's done. What I've also done is given myself enough space so that way I can change the bits without having to move this thing, because I don't want to move it off center now that it's all locked into place. The final thing I need to do is to set the depth that the drill bit's going to go. So to do that, I'm going to bring it down and just have it touch the surface of the handle. And now I can go ahead and adjust the stop on my drill press. And the tang is 1 1/8, so I'm going to go 1 3/8 inches just to give myself an extra 1/4 inch because I don't want it to bottom out at the bottom of the hole. I want the bolster, which is the big part of the tang, to seat up against the end of the handle. Now all that's left is to drill the hole, and I'm starting with a 1/4 inch bit because that'll give me the clearance for the skinniest part of the tang, and then I will gradually work my way up in steps until I get close to the top width of the tang. I've got the second drill bit in and I've reset the depth so it'll go down 1/2 inch. At this point, I'm using the tang as a crude drill bit to help drill its own hole in the handle, because nothing's going to make a better taper to fit that tang than the tang itself. So I turn it a few times, then I clean off the sawdust, and I turn it a few more times. You want to take your time with this step because the key is to get it so it cleans out enough material that you don't split the handle when you drive it home, but you don't want to make it so loose that it falls out unintentionally. Okay, I've got it so it's about 1/4 inch from bottoming out, and that's right where I want it. So I'm going to turn it and pull it back out one more time, clean out the sawdust, make sure there's no sawdust packed down in the handle that would keep it from bottoming out, And we need to look at this tang real quickly. And you'll see that it's not a 90-degree angle right here. There's actually a little bit of a fillet all the way around. And the easiest way to make the matching bevel is with a countersink bit. And once again, clean out the sawdust. This is actually a rectangular taper, and what I mean by that is it just barely tapers at all in this direction. Most of the taper is in this direction, so you can think of it as a cut nail. And just like with a cut nail, you want the big part of the wedge to run parallel with the grain. I want this to run parallel with this grain, so I'm going to line it up so that way the grain in the handle aligns with the widest part of the taper. And now I just drive it home. That's really all there is to putting a handle on a tanged chisel. So let's see, we've got socket chisel, tang chisel. And that's how we make handles for chisels.